Using this diagram, we will understand how an IPM works. The first thing we need to do is to identify the inputs and outputs. We are always talking about electrons. Remember that electrons enter through the negative terminal and exit through the positive terminal. And at this point is where we have the DC power supply of 310 or, depending on its voltage, 155 or 180 volts in DC, which comes rectified and everything prepared to create it in three-phase. This device will transform the DC current into AC. That is why the IPM, the main component that gives the name to the inverter. Well, at this point we had the input of direct current, but in these 3 points U, V, W, that is how a three-phase voltage offset is represented with those letters. They are not abbreviations of anything, not even the initials of any word. They simply point to a sequence that we have connected in these 3 points. Well, in those 3 points it is known where the coils are connected. We have a coil here, we have another here, and here we have another. And what we have to do is that between those 3 coils of the compressor motor, let's turn or pass the electrons at different times. We have to make the electrons go in that direction, and we also have to make the electrons go in the opposite direction, and at different times. How does this happen? Well, here we have 6 points that are going to enable 6 electron bypass keys. They open and close, and all this at different times. What happens, for example, if I open this key through a notification at that point, and I also open this one? If I open this and open this, the electrons will enter through here, cross this key, and exit through here. Then, by deduction, they will cross, I drew this point wrong. By deduction, they will cross the coil that is between U and between W. They will cross this in this sense. Now, what happens if I don't want the electrons to go from U to W, but to go from V to U? Well, that is also simple. What I have to do is, instead of opening this and this, now I have to open this and this. Then the electrons will enter through this side, they will enter through there, the gate that is open. They will cross from W and they will go to U because this is the one that is open to exit. We cross the same coil but towards the opposite side. If I open these 2, the electrons enter and exit through here. If I open these 2, the electrons enter and exit through here. If I open, for example, this gate and this, what will the electrons do? Well, the electrons will enter through the side that is allowed, and they will exit through the side that is allowed. What coil will they cross? They will cross U to V. So, they will cross U to V. If I want to go from V to U, if you want to go backwards, and well, these 2 are reversed and open the opposite ones. So, in that case, I open this and this, and the electrons will enter through this point, cross from V to U, and exit through the positive. We always enter through the negative and exit through the positive. That is always the case because there is DC, but I make the electrons pass from U to W, from W to V, from V to U, from U to V. I change their direction by opening synchronously different gates. And this is how the three-phase current is created in an inverter compressor. One important detail is that even the compressor motor is part of the electronic equipment. The compressor motor is part of the electronic equipment because for the circuit to finish working it needs the compressor. This is why an inverter it is so complex, because even the last coil of the compressor is an integral part of the electronic system of the entire electronic circuit of the equipment. That is why we cannot make inventions like placing any compressor, any IPM. Everything is completely synchronized and configured, and everything in order. Now, look at the points that I am going to mark now. Let's see. Let's tidy it up a bit. And we will mark with red the points of the IPM of the thick side. That is, these points that I am going to mark now are the thick side of the IPM, the side that the voltage enters and the strongest voltage leaves. But what is all this? Well, all these points that come from the microprocessor, a delicate part of the board, are the ones that I am going to mark now with green. They are the notices, so that perhaps the gates open at the time that the microprocessor wants. They are also sampling points of the input of the electrons to the different differentials of the different gates. These gates, in reality, are IGBT. It is a special form of transistor to support high current and high speed. They are also not JVT or MOSFET. In case anyone asks, they are IGBT, and they are powered with 15 volts. We will talk about this later, but I will tell you in advance, they are powered with 15 volts and there opens the gate and lets the electrons pass. I will explain this later. All these green points, and we still have more. We also have here, and look at these are direct samples of U, V, W, and here we have two more. All these green points are these sides. This side, excuse me. It controls how the electrons enter, controls how they exit to the coils, controls the state of the coils, activates the gates and measures the temperature. It is a complex circuit that is in direct contact with the microprocessor. This is how the IPM works, creating the three-phase alternating current for this three-phase motor to work. Depending on how it opens these gates, at what time it does it, the compressor motor rotates faster or rotates slower. Excellent, this is the circuit here as we see it. Now we will move on to seeing it on the boards, and then we will move on to controlling this component to know how it is measured. One detail that I want to mention before finishing this part, these diodes, how these gates open and close constantly, a spark is produced. These diodes, in this position, consume the spark so that these gates are not damaged quickly. These diodes consume that energy, and they are always placed between the output of the compressor and the negative and positive poles, but of course they are placed in reverse, and direct. We will talk about that later, but that was the component that I needed to explain to you. Now, let's go on to see it on the board and make measurements on the IPM and also on a three-phase inverter compressor motor. Please leave a comment if you have any questions.